Okay. Now just see here. So what is the basics of this current electricity? The basics of this current electricity is, first of all, what is the meaning of resistance? जो बोला है वो नहीं बोलता, जो और जरूरत है इसका। मैं क्या सोचा, तुम ऑलरेडी इसके बारे में बता बोले सोचा, फिर let us discuss what is the basic of this electricity. Okay, so you all know that resistance is directly proportional to length, resistance is inversely proportional to cross sectional area, and resistance is directly proportional to L by A. Resistance is equal to rho L by A. This is the basic concept of resistance. You all know about that, isn't it? Okay. So from this, what do you understand? If the wire is having length L1, if the length of the wire has been doubled, if L1 is L, L2 is 2L, okay, and area of cross section is same, then what happens to the resistance? When length is doubled, what happens to the resistance? Double. Length is also doubled means what happens to the resistance? It is also doubled because it is a direct relation. For example, if length is same, area of cross section of the wire is A first, then area has become 2A, doubled. Area has been doubled. What happens to the resistance then? Length is same, material is same. Material is same means rho is same here. Okay, rho means specific resistance. Specific resistance is constant for a particular material, isn't it? So this is a basic concept that resistance is inversely proportional to cross sectional area. If area is doubled, resistance becomes half. You know about this, isn't it? Up to here it's okay. Then the next thing is cross sectional area can be considered as pi r square. Am I right or not? You can take it as pi r square. Okay. So then what else you will be getting now? Resistance is equal to rho L by pi r square. So what do you understand from this? Resistance is inversely proportional to r square. Okay. Then resistance is inversely proportional to radius of the wire. So if radius is doubled, what happens to the resistance?
4 times.
1 by 4 times. Inverse relation. See here, if R1 is equal to R, R2 is equal to 2R, that means R2 by R1 is equal to R1 by R2 whole square though. Am I right or not? It's an inverse relation, no? Is it not an inverse relation here? Do you understand what I am saying now? It's inverse relation. So if the resistance of the wire is R, if it has been doubled, it has become 2R, then what happens to the resistance? R2 by R1 is equal to R1 by R2. R1 is R, R2 is 2R, is going to be whole square. So therefore, R2 by R1 is going to be 1 by 4. That means R2 is equal to R1 by 4. This is a simple concept, isn't it? This is a simple concept. Everyone knows about this, isn't it? Everyone knows about this. But what happens? See, this is applicable when extra length is added. This concept is applicable. Already there is a wire, extra length is added here. Already area is there, extra area is added to that. Extra. Then these formulas are applicable. What are the formulas applicable for extras? Okay, for extras, the first relation is R is directly proportional to L. The second relation is R is inversely proportional to area. The third relation is R is inversely proportional to R square. This is applicable only when present length, extra length is added. Present area, extra area is added. Extra. If it is not extra, already there is a wire. Okay, already there is a wire. Okay, this much wire is there. I am not adding any extra length to that. The same wire I am melting and stretching. Same wire I am melting and stretching. Previously area was A1. Now area has become A2. Previously length is L1. Length increases, area of cross section decreases. But what is going to be same here? What is same here? Volume is same. This is a just like cylinder, no? How much material you are using here? The same material is present here also. So volume is same. So volume is remaining constant in both the cases. Volume is same. So what I am saying is, okay, so in stretching cases, these are all, you just remember, it is these are all stretching cases. Not extra length is added. Whatever the length is present, that has been pulled, that's it. No, nothing from outside. The same length has been, the same wire is changed to different dimensions. Then what happens? What happens to the length first of all? So for that you just remember, R is equal to rho L by A. And you all know, volume is equal to area into length. I want what is the relation between resistance and length. I don't want area. Then should I not replace this area now? Area should be removed. I don't want the relation between area. I want the relation between length and resistance in the stretching cases. For that what I will do? Instead of area, I will take volume by length. So I will substitute here now. Then what I am going to get? Resistance is equal to rho L by A. A means V by L. So R is equal to rho L square by V. So in this case, what is going to be constant? Volume is going to be constant, isn't it? Volume is going to be constant. So create a formula in which length is present, which is a variable, and add one extra physical quantities which is a constant, and rho is already constant because it is we are not changing any material, right or not? You are not changing any material. So from this what do you understand? Resistance is directly proportional to L square. New relation. So this is where children are going to get confused. What happens when resistance is doubled? What happens when length is doubled means you write resistance is doubled. But you won't read in the question that the wire has been melted and doubled its length by stretching. Then you can't use the same relation. R is directly proportional to L. You should use the relation R is directly proportional to L square. That you should remember. Volume is constant, rho is constant. That's the case here. There are many previous year questions related to that. The next thing is here. This is a wire now. This is a wire now. Okay. Now we are considering that you are melting and you are stretching. Then previously length was L1, here length was L2, volume was same. Area was A1, here it is A2. So now the same formula I am using, rho L by A. Now I don't want the relation between resistance and length. I want the relation between resistance and area now. Okay, and volume is constant here. So what I am going to do, volume is equal to area into length. Okay, and I don't want length, I should replace length now. Length can be taken as volume by area. Length can be taken as volume by area. So therefore resistance is equal to rho. L means what will you write? V by A divided by A. So resistance is going to become rho V by A square. So in this I have created one variable, two constants. I told you that when you stretch something, volume going to be constant. Specific resistance is anyhow constant because I am not adding any extra alloy. Same material, only stretching is there. So here there are two constants. There are two constants. Rho is constant, V is constant. Now I got a new relation. Resistance is inversely proportional to A square. Not like extra length added or extra area added. In extra area added, R is inversely proportional to area. But while stretching cases, R is directly proportional to L square. R is inversely proportional to A square. And one more thing is, you all know area is nothing but pi R square. So resistance is inversely proportional to pi R square whole square. So resistance is inversely proportional to R power 4. In specially stretching cases, the relation between resistance and radius is nothing but it is inversely proportional to R power 4. In the previous case, what is going to happen? In stretching cases, without stretching cases, R is inversely proportional to R square. Just extra length added, extra area added. Inversely proportional to R square. But this is a special case. Stretching cases, then R is inversely proportional. So what are the new relations we got now? The first thing is I got a relation R is directly proportional to L square. If length is doubled, resistance becomes 4 times. Okay. Now, this is the next relation is R is inversely proportional to A square. When area is made to half, when area becomes half, then what happens to resistance? It becomes 4 times. Inverse relation, no? It becomes 4 times. Previously, if it becomes half, resistance becomes double without stretching, only extra length added. But here, what happens? Area becomes half, resistance becomes 4 times. Stretching cases. Then what about radius? If radius gets doubled, what happens to resistance?
80 times.
Doubled. 16 times.
16.
Doubled, no? 2 power of 4. 2 to the 4. One more 2 pairs of 2's. 2 to the 4. 2 to the 4. 4 to the 16. So if radius doubles, resistance becomes 1 by 16 times. I'll tell you how. See, I told you that resistance is inversely proportional to what is that? R power 4. So previously you have taken a wire in which radius is R. Okay. You have taken one more wire. Okay. Whose radius? See, this is R1 is R. R2 is 2R. Right or not? So what I have done, in this case, I have taken a wire. I have melted that wire. The long wire I have melted and made it short. When you made it short, length decreases, area increases. Right or not? That's it. So this was a very long wire. I have made it short by just melting, and radius has become doubled now. So when R1 equal to R, R2 equal to 2R, so R2 by R1 is equal to R1 by R2 whole power 4. So therefore R2 by R1 is equal to R1 is R, R2 is 2R. This is going to be 4 times, then this is going to be 2 by R1 is equal to 1 by 16. So therefore R2 will become R1 by 16. So this is going to be your new formula. Is it understood? In stretching cases, if radius becomes doubles, resistance becomes 1 by 16 times. If radius becomes half, resistance becomes 16 times. Yeah, 1 by 16, they have 16 into. I'll do that example also. See previously, this was the radius, R1 equal to R. Now you have stretched it. R2 has become R by 2. Stretched means length increases, radius decreases. I told you that R is inversely proportional to R power 4 in stretching cases. Okay, so therefore R2 by R1 is equal to R1 by R2 whole power 4. So therefore R2 by R1 is equal to R1 by R2. R1 is how much? R. R2 is how much? R by 2 whole power 4. Getting cancelled. So 2 comes to the numerator. R2 by R1 is equal to 16. Therefore R2 is equal to 16 times of R1. Hope you are understanding what I am saying now. Is it clear? So stretching cases. He may not say stretching sometimes. He may say a wire is taken, it has been melted and drawn into a thin wire whose length is double. Drawn with both. If he doesn't use the word stretched, he says drawn. Hope you understand. So this is one basic concept. What is the next basic concept which is present in this? The next basic concept is, let us take one small concept here. I have taken a wire of length L1 which is equal to 1 meter, and temperature T1 is equal to how much? 0 degrees Celsius. Okay, so I have heated this wire to how much? 100 degrees Celsius. Length has become L2. Length has raised to L2, and I have taken this one. And the extra length after heating, see, whatever the item you heat, whatever the body like metal you heat, when you heat, it expands. Metal you heat, metal expands. There are few things which does not expand, which will contract after heating. What is that? Thermocol, you heat, it contracts. Plastic you heat, it contracts. Foam you heat, it contracts. So plastic materials will contract after heating, whereas metals will expand on heating. The best example given in your IP material, between the two rails gap is left. Why gap is left? So that insects will pass through that. Huh? The gap is left in summer, it may expand and it may touch. In winter, if there is no gap, in winter only it is touching each other. In summer, what happens? It will expand, it will rise like this. So there will be speed breakers in railway track also. So gap is left through that. In summer it expands, and some gap is less. Gap will be filled in summer. Every item expands on heating. Okay. So here also 1 meter rod, if you heat, it increases its length to 1 mm. Huh? Okay. So what do you understand from this? You will understand from this that increase in the length is directly proportional to actual length. How do you say this one? I have taken one more example. I will take one more example here. So instead of 1 meter rod, I am taking L1 equal to 2 meters. And I am heating that rod. So previously this temperature was 0 degrees Celsius. Now the temperature is going to be 100 degrees Celsius. So now this is increasing its length to 2 mm. 1 meter rod, if you heat to 100 degrees Celsius, 1 mm is increased. 2 meters rod, if you need to heat to 100 degrees Celsius, 2 mm is increased. What do you understand from this? You will understand from this that increase in the length is directly proportional to actual length. Increase in the length depends upon the actual length. Okay. For example, you have heated the same rod to 200 degrees Celsius. Then increase in the length becomes 2 mm now. So one more relation you are getting. Increase in the length is directly proportional to rise in temperature. Increase in the length is directly proportional to length. Increase in the length is directly proportional to increase in temperature. If you join these two, you will get a new relation. Okay? You are going to get a new relation. What is a new relation? L2 minus L1 is directly proportional to L1 into T2 minus T1. So when you remove this proportionality, you will get L2 minus L1 is equal to alpha into L1 into T2 minus T1. So from this it is understood that alpha is equal to L2 minus L1 by L1 into T2 minus T1. Okay. So this can also be written as what is this alpha? Coefficient of expansion, which is present in the heat chapter. Where alpha is equal to how much? Increase in the length by actual length into rising temperature. Delta L is nothing but L2 minus L1. L is nothing but original length. T2 minus T1 is written as delta. So why are you explaining the heat chapter here? I am explaining the heat chapter here because resistance is directly proportional to length. I am just replacing length with resistance now. So I am just writing this formula. Which is present in heat chapter, that is expansion of solids, liquids and gases. There is one chapter called as heat. Expansion of solids, liquids and gases. I am just replacing this alpha as R2 minus R1 by R1 into T2 minus T2. Hope you are understanding. So based on this, there are many problems in previous year questions. You can just see. Sometimes he now just I have solved one problem. Just now I solved that. Girl asked for doubt here. I have solved that problem. He is telling that R2 is equal to how much? 8.6 ohms it is given. R1 is equal to 2 ohms it is given. Temperature T1 is 0 it is given. Temperature T2 is 80 degrees Celsius. This type of previous year questions are asked. So these resistances values have been given. I think first question in that material. वो material में है. This is some other question in your material. से previous year question क्या था? ये क्या था? Okay. So anyhow, now after giving these values, he is asking the alpha. Take these values, substitute and get the answer. Hope you understand what I am saying. Okay. So if you understand this one, then let us understand what happens in resistance in series, resistance in parallel. Okay. Resistance in series. See, I have taken one resistance and another resistance. Both are connected in series. And this is the potential difference. So what is this resistance now? This is R1 and this is R2. this potential which is present here gets divided here. This is V1 and this is V2. Okay, and as there is only one series, one wire here, the same current flows. Here potential gets divided but current is same. What is the condition here? This is the case of series connection in which I is same whereas V is divided. That means what will you write? Then you write V is equal to V1 plus V2, and according to Ohm's law, V is equal to IR, V1 is equal to IR1, V2 is equal to IR2. I is same because it is series connection. There is no other way for current to go. It has to pass through a single wire. So here V means I write R series. Okay, V series is nothing but I into R series, and this is I into R1 plus I into R2. So I gets cancelled. So R series is going to become R1 plus R2. If one more resistance is added, which is R3, then you get R series is going to be R1 plus R2 plus R3. The basic concept here. Now one resistance is here, another resistance is connected in parallel. This is R1, this is R2, and they are being connected to a single potential, that is V. So what do you understand from this? Here, as this parallel connection, this resistance is separately connected to this voltage, that resistance is also separately connected to the same potential. So you understand that in this case also potential is V, in this case also potential is V, but here current is I1, here current is I2, here current is I. The same current comes up to here, and here there are two ways. So some of the current will pass through here, some of the current is passing through here. So in a parallel connection, what is the condition in the parallel connection? V is same, I is divided. In the previous case, if you observe, I is same, V is divided. The next thing happens here. I is divided, V is same. So whatever it is divided, you should write I in parallel is going to be I1 plus I2. Okay? As V is same, you can't add V. What is divided, that is going to be added. Here, in the previous case, potential is divided, so potential is added. How can you add I? I is only 1. So here, current is same. And you all know according to Ohm's law, V is equal to IR. I parallel is equal to V by R parallel. I1 is equal to V by R1. I2 is equal to V by R2. Just add them. V by R parallel is equal to V by R1 plus V by R2. So therefore, what are you going to understand from this? V, if you common out and cancel, getting R parallel is equal to 1 by R1 plus 1 by R2. If one more parallel connection is given, which is taken as R3, what are we going to get from this? Isn't it? Yes. So you get extra you get. What is that? 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here R parallel, you just take LCM. 1 by R parallel is equal to R1, R2 is the product of, the LCM is going to be the product. And here you write R1 plus R2. Therefore R parallel is nothing but R1, R2 by R1 plus R2, isn't it? So here it is the three cases. So 1 by R parallel is going to be, LCM is going to be just the product, R1, R2, R3. So R1, if you common out, what is left? R1, R3 is left. Okay. So you can write here R1, R2 plus R2, R3. In order I am writing plus R3, R1 you are getting, isn't it? Okay, so R parallel is going to be, if three combinations are there, what do you write? R1, R2 plus R2, R3 plus R3, R4. So this is a shortcut formula for parallel connection. When there are two R1, R2 by R1 plus R2, when there are three R1, R2, R3 by R1, R2, R2, R3, R3, R1, isn't it? Next, for example, this type of resistances are there, where here one resistance is there, 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 and let us imagine all are same. What is that? This is R, this is R. So this is R, this is R, this is R, this is R, this is R. What are going to be parallel here? What are going to be series here? So these two are series. That's going to be 2R, and this is parallel with R. So 2R into R by 2R plus R is going to be 2R square by 3R. So getting cancelled. So you're getting 2R by 3 here. So what is the upper part? It is going to be 2R by 3. And this 2R by 3 is connected to 1R, and this connected to 1 more R. Now series connection means you just add them. You write R plus 2R by 3 plus R. That is going to be A. This is going to be B. I am asking what is RAB. So you just can add and tell the answer. No. So what is going to be the answer? So 3R plus 2R plus 3R divided by 3. So it's going to be how much? 10R by 10R by 3 or 8R by 3? 8R by 3, isn't it? Okay. And regularly one more type of question is asked. Many a times it has been asked. Yes. See, like this, the diagram is present, and here it is connected to the potential. Okay. So what are the things you are going to see here now? Here there is resistance R. Here there is resistance R. Here there is resistance R. This is 2 times asked in the previous year questions, and he is asking us to find out what is the current passing through this. Okay. The formula is I is equal to V by R net. Single voltage is there, but currents resistances are many. Resistances are many. So from this you will understand that these two are in series, and these two are in parallel with this. So when 2 are series and parallel with this, so this upper part is going to become 2R, and it is parallel to this R. So 2R into R by 2R plus R is nothing but 2R square by 3R. So getting cancelled. So I is going to be V by R net, which is nothing but 2R by 3. So 3V by 2R is going to be the answer. What is given? The values are given here. Something. See, 77 question number. It is given 333. So here also, in the question itself, it says that this is 3 volts. This is 3 ohms. This is 3 ohms. This is 3 ohms. Means. What is that resistance? R is how much here? 3. You just substitute 3 here. So 3V by 2, 3. 2 into 3. Because R net is how much? R net is how much here? 2R by 3, no. Where R is 3 here. So 2R by 3 means 2 into 3 by 3. When you cancel 2 is left now. R net is how much? 2. So 3V by 2 is the answer. समझ में आ रही बात? कौन सा? नहीं समझ में? See, a triangular shape here. Potential. What is the value of the potential? Is it given? 2V. 2V? Yes. Okay. Net potential is 2V. Okay. So net potential here is 2V. Here there is a resistance. How much it is? 3 ohms. Here 3 ohms. Here 3 ohms. So these two are in series. So 6 ohms. Okay. And this 6 ohms is in parallel with 3, no? So 6 into 3 by 6 plus 3 is nothing but 18 by 9. 2 ohms is your answer or not? So what is R net here? 2 ohms. So I is equal to V net by R net. So I is equal to, what is V net? 2V? 2V? 2 volts. 2V net, 2 volts. So 2 volts. So V net is nothing but 2 volts and R net is nothing but 2. So your answer is 1 ampere, isn't it? And one more here, he has asked like this. He has taken a triangle, okay, and he has taken this resistance, and this resistance. I think this is 6 ohms and 6 ohms, and this is 3 ohms, right or not? Same? Or something else? Same. And here, they are connected to potential. What is the potential given? 4.8 volts, isn't it? Now. So you have to find out the current in this case, am I right? Current you have to find out? Yes.
current you have to find out. That means I is nothing but V net by R net. R net, how will you find out here? 6 plus 6 is how much?
12.
So this combination is 12. And 12 is in parallel with 3. Is it correct? So what do you write now? 12 into 3 by 12 plus 3. Okay. So 12 into 3 by 12 plus 3. 12 into 3 you write like that only, and this is going to be 15. Alright? So 3 ones, 3 fives. So what is R net? R net is 12 by 5. And this is how much? 4.8 divided by R net, which is how much? Which is 12 by 5. So I'll write like this: 12 ones, 12 4 times, 5 fours are 20. R net is going to be 2 ohms. 2 amps, sorry. क्या करेंगे? अब तो R net is to find out. Sorry, I is find out करनी. This is going to be I now. I is nothing but V net by R net. V net is how much? 4.8. R net is how much? 12 by 5. So I is equal to V by R net. I is equal to V net by R net. V net is how much? 4.8. R net, how much you are given? 12 by 5. So 12 divided by 5 means 4.8 into 5 by 12. 12 ones, 12 fours, 0.4. So 4 5 is 20. So 20 point here. So answer is how much? 2 amperes. Is it okay? Shall we stop? Let them go. जाते हैं.